everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5, Continuity and Differentiability in Exercise 5.2, ninth sum. So prove that the function f given by f of x equal to modulus of x minus 1, where x is belongs to some real value, is not differentiable at x equal to 1. So basically the given f of x is not differentiable at x equal to 1. We have to prove it. Okay. And for proving this, generally if any function is differentiable, we need to prove that left hand derivative and right hand derivative are equal. So if it is left hand derivative, right hand derivative, if it is same, then we can say the function is differentiable at whatever given point. Okay, so first let's understand what is the left hand derivative formula. So differentiation generally we will represent with the f dash. Okay, so for left hand derivative f dash of x, so if f of x is given, the differentiation of f of x is what? F dash of x. Okay, so f dash of x equal to limit h is approaching to 0, f of x minus h minus f of x by minus h. This is the formula for the left hand derivative. And for the right hand derivative, f dash of x equal to limit h is approaching to 0, f of x plus h minus f of x by h. So on simplifying this, both the left hand derivative, right hand derivative, if the results are same, then we can say that the given f of x is differentiable at x equal to 1. Okay, if it is not same, if the left hand derivative result and right hand derivative result, if both are not same, then we can say it is not differentiable. So it's a proving question. So they're asking us to, it's not differentiable. So obviously left hand derivative, right hand derivative, the result is going to be vary. Okay, so now let's find out left hand derivative first. And what is the given function here? Given f of x is modulus of x minus 1. Okay, so left hand derivative, let's find out first. So left hand derivative, what is the formula? F dash of x equal to limit h is approaching to 0, f of x minus h minus f of x by minus h. Now, in a given question, what is the f of x? Modulus of x minus 1. So basically whatever input you have, that we have to take like modulus of x minus 1. Okay, so we have to take the modulus, then subtract 1. So here this completely x minus h, treat it as a x, take the modulus of that input, that x minus h, limit h is approaching to 0. So taking modulus of that x minus h, then with that what we have to do? We have to subtract minus 1. Okay, and what is f of x? The given function as it is, let's write it. That is modulus of x minus 1 divided by minus h. But in a given question, it's not differentiable at x equal to 1, no? Now replacing x as a 1, okay? This is f dash of x. So f dash of 1 value, we have to find out. Limit h is approaching to 0. Wherever you see x, no, just replace it as a 1. So 1 minus h minus 1 minus modulus of 1 minus 1 divided by minus h. Now here plus 1 minus 1 will get cancelled, and here 1 minus 1, which is 0. That means completely second term becomes 0. You will not have a second term. So now we have only the first term. So there limit h is approaching to 0. In the numerator we have modulus of minus h. Denominator minus h we have. So what is meaning of the modulus? Even if the term is negative, we have to take it only positive. So modulus of minus h gives you only positive h divided by minus h. Now h get cancelled. Now limit h is approaching to 0. 1 by minus 1. 1 by minus 1, what is that? Which is minus 1. So limit h is approaching to 0 is minus 1. Now there is no variable in the terms of h. So basically it is a constant. Applying the limit for the constant, which is constant itself. So answer is minus 1. So our left hand derivative giving the result as a minus 1. Now right hand derivative we have to find out. Okay, for right hand derivative we are going to use this particular right hand derivative formula. So limit h is approaching to 0, f of x plus h minus f of x by h. For right hand derivative, let's find out now. So f dash of x is limit h is approaching to 0, f of x plus h minus f of x by h. Okay, and what is the f of x in the given question? Modulus of x minus 1. So whatever it's given as an input, we have to take the modulus, then we have to subtract 1. So here the first part, what is the input here? F of x plus h. So completely treat this as a x, right, as per the given function. So we have to take modulus of x minus h. Okay, then we have to subtract 1, minus 1. Now minus f of x is what? Exactly the same function, x minus 1 whole divided by h. Now, in the given question, what is the x value? They said x equal to 1, no? Replacing x as a 1 now. Now, limit h is approaching to 0, 1 minus h minus 1 minus modulus of 1 minus 1 divided by h. Okay, 1 minus 1, which is 0. Second term fully it's a 0. Then here in the first term, no, plus 1 minus 1 cancel. Now limit h is approaching to 0. You will have modulus of minus h in the numerator and divided by h. Okay, modulus of minus h is, since it's a modulus, we have to take only the positive term. So it gives you only positive h divided by h. H cancel. Okay, then limit h is approaching to 0, 1. Okay, h cancel, the result is 1. Since it's a constant function, applying the limit, what happens? Same result you will get, which is 1. So f dash of 1 is what? 1. So let's take this as a equation 2 and the left hand derivative result as a 1. Now if you notice that left hand derivative result, here f dash of 1 says minus 1. Here f dash of 1 says positive 1. It's a mismatch, no? So from 1 and 2 we can say that, from 1 and 2 we can say minus 1 not equal to positive 1. Okay, so that means minus 1 not equal to positive 1, that is left hand derivative not equal to right hand derivative. So we can say that the given function, given f of x equal to, that is modulus of x minus 1, is not differentiable at x equal to 1. Differentiable at x equal to 1. Okay, that's all the solution. Thank you for watching and please do subscribe. Thank you.